Hi dear students, welcome to Mahila Samaja online class. Now you are all watching 9th standard physics class. Now in this class, we are going to study about continuous class of motion. Okay students, so from this, we are going to learn about these points, that is meaning of acceleration. Second one is a rate of change of velocity or acceleration time graph. Third one is equations of motion, which is related to acceleration, and so problems based on the acceleration. Okay, students. So let us study these things one by one. First one is meaning of acceleration. The change in velocity of an object per unit time is called acceleration. Once again, dear students, the change in velocity of an object per unit time is called acceleration. Okay, so its formula is acceleration is equal to change in velocity divided by time taken. Okay, so once again, the formula acceleration is equal to change in velocity divided by time taken. It means we are going to find out the acceleration by using this formula, right? So let A be a acceleration and U be the initial velocity and V be final velocity. Then its formula become A is equal to U minus V divided by T. Okay, students. So its SI unit is meter per second square. Okay, here velocity is meter per second. Here also meter per second. Here time is in second. So due to that one, so its SI unit is meter per second square or ms to the power of -2. Okay, students. So next we want to study about uniformly accelerated an object. It means we are going to study about the graph. Before that, we want to study these two topics. So here, uniformly accelerated an object means if an object travels in a straight line, it means path, and its velocity is increases or decreases by equal amounts in equal interval of time. That one is already we are studying in the last class. It means equal distance which is covered by equal interval of time. That is the meaning of uniformly accelerated an object. For this, we should have to take one example here. Velocity of a car at regular instant of time. Let us take these two. Time is in seconds, velocity in meter per second. At starting, it is time is 0. Your velocity is also 0. So after 5 seconds, so velocity of an object is 2.5 meter per second. Next 10 seconds, so it should be 5 meter per second. 15 seconds, 7.5 meter per second. So on like this. So 30 seconds, so velocity of an object is 15 meter per second. Just observe here. So your time intervals, it should be a 5 seconds each, right? So here your velocity of an object is 2.5 meter each. It means so regular intervals. It means regular intervals of time we should be cover equal distances. So that is nothing but uniformly accelerated an object. Okay, students. Right. So next is non-accelerated an object. An object which is traveling along a straight road or a path increases or decreases its velocity by unequal amounts, okay, in equal interval of time. It means time is equal intervals, your distance covered is unequal. So that is nothing but a non-accelerated an object. Okay, students, for this we shall take one example. Rama and Lakshmana, two brothers, are going to a school from his home, right? So they are using the time, distance traveled by Rama in kilometers, distance traveled by Lakshmana in kilometer. So they are going to leave house at 8 a.m. So it means at 8 a.m. both of them are leaving the home. Okay. So next, after 5 minutes, so they are going to reach Rama reached 1 kilometer, but Lakshmana reached 0.8 kilometer. So after 5 minutes, this means 8:10 a.m. So Rama reached 1.9 kilometer, but Lakshmana reached 1.6 kilometer. So after 8:15, it means after 5 minutes again. So Rama reached 2.8 kilometer, but Lakshmana reached 2.3 kilometer. So at 8:20 a.m., it means after another 5 minutes. So Rama reached 3.6 kilometer, but Lakshmana reached 3.0 kilometers. So what it is indicating, dear students? So here your time intervals should be the same. It means 5 minutes each. But here distance, just you can observe they are covering unequal distances is a trade. So it is indicating that so non-accelerated and objects. Okay, students. From this we want to study more about these things. So here we should have to make an important note. Acceleration has to take based on these points in the calculation part. It means these 2 points are playing a major role while you are calculating the acceleration in the problems. Okay, first one is acceleration is taken to be positive if it is in the direction of the velocity. Okay, object which is going in the direction of the velocity, so its acceleration must be taken as a positive. Okay, students. So the second one is acceleration is taken to be negative when it's opposite to the direction of the velocity. Okay, students, right? So from this we should study about the graphical method of acceleration and time graph. Here also we should to study about two things, that is uniformly accelerated objects. So just you can take here your acceleration means what? So it is a change in the velocity, right? So it means we should have to take the velocity on y-axis as well as the time on x-axis. So here uniformly accelerated object means so it should be cover equal distance and equal intervals of time. It means we are going to get a straight line. Okay, students. So uniformly accelerated objects always represent in a graph as a straight line. Okay, so next is non uniformly accelerated motion or objects. All right, so here just we can observe here unequal distances. It means unequal amounts of distances which can covering in a equal intervals of time. Here also you should take a velocity on y-axis as well as the time on x-axis. So here unequal distances in equal intervals of time, right? It should be representing your velocity time graph of an object in non-uniformly accelerated motion. Okay, students. So right, next one is equations of motion related to acceleration. So here from this we have a first equation, that is velocity time relation. From velocity and time relation we have a great equation. It is so that is v is equal to u plus at. So whatever the symbolic forms we should be representing here, your u is equal to initial velocity, v is final velocity, your a is acceleration, your t is time. So second equation is equation for position and time relation. Position means so it should be cover some distance, no, or displacement. That is meaning of position and time relation. So here we have a equation, that is S is equal to ut plus of at square. So these terms or symbols it should be indicating here. S means displacement, it means position of the object. So u means initial velocity, v means final velocity, a means acceleration, t means time. So next third equation is so position and velocity relation. Position means displacement or distance. So along with velocity we should take relationship here, that is v square minus u square is equal to 2as. Here the terms are u is equal to initial velocity, v means final velocity, a means acceleration, and s means displacement. By using these equations, let us solve some problems here. That is, first problem is a car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate. First one is acceleration of an object. Second one is distance covered by an object by a car in that time. Okay, for this we have a solution. First we should collect the data. So initial velocity is given, u is equal to 18 km per hour. So kilometer per hour we are going to convert in meter per second. For that, 18 into 1 kilometer means 1000 meters. So per divided by hour means 60 into 60 means 3600 seconds. Right, after simplification, so your initial velocity is 5 meter per second. Similar way, your final velocity 36 kilometer per hour, which is converted into meter per second, that is 10 meter per second, and time is given 5 seconds. You are going to find out acceleration as well as a distance of the car. So first we want to find out here acceleration. So by using the equation, that is v is equal to u plus at. So we need acceleration. Send u to LHS, it should become negative. Then at is equal to v minus u. Then a is equal to v minus u by t. Substitute the values of v, u and t here. A is equal to 10 minus 5 divided by 5 meter per second square. Then a is equal to 5 divided by 5. Then acceleration of an object is 1 meter per second square. Okay, students, understood this problem? All right. So next it is here. You should find out the distance. So distance means S is equal to ut plus of at square. So here S is a distance covered by an object. Displacement you should say, okay, that is equal to u is the initial velocity 5 meter per second into t is 5 seconds plus of into your acceleration is 1 meter per second square into t means 5 seconds whole square. Yes, square is there, no, t square, that's what. Okay, so next simplification, here a second and second get cancelled. Now it should become 5 5s are 25 meter plus here. So this is 1 divided by 2 is 0.5 meter per second square into 5 5s are 25. Yes into yes, s square. Now in this step, s and s square is get cancelled. Then that is equal to 25 meter plus 12.5 meter. It should be gives you, so S is equal to 37.5 meter. So it means, so that a car can be covered a distance 37.5 meter. One more example problem here, that is a bus is starting from rest. Observe this point, okay, from the rest, move with a uniform acceleration of 0.1 meter per second square for 2 minutes. Full stop. Find first one, speed acquired by a bus. Second one, the distance traveled by a bus. Okay. Okay, students. So for this, we have a solution. So first we shall collect the data. Initial velocity, bus is started from the rest means, so your initial velocity become 0. Then your acceleration of the bus is 0.1 meter per second square. Then time is given, that is 2 minutes. So you can convert in seconds, that is 2 into 60 seconds, that is equal to 120 seconds. Now you want to find out here speed as well as a distance. Okay, so first one, so using a formula, v is equal to u plus at. Substitute the values here. Initial velocity is 0 plus your acceleration is 0.1 meter per second square into 120 seconds. 1 second get cancelled here. Then your speed of the bus is 12 meter per second. So in that time, so how much distance should be traveled? So by using S is equal to ut plus of at square. Then initial velocity is 0 into your t is 120 seconds plus of into your acceleration is 0.1 meter per second square into time is 120 seconds whole square. Then simplify this, that is 0 plus of into this 0.1, I can rewrite as 1 by 10 into 120 into 120 meter. It means second square get cancelled here. Okay, next it is 60 into 12 meter. Then your distance of the bus is 720 meter. Okay, students, so this much we have studied in this class. Based on this, please take the homework. That is, first question is, what is mean by acceleration? Write its formula and SI unit. Second one is, write a general acceleration and time graph for uniform motion. Third one is, write difference between velocity and acceleration. Fourth question, write equations of motion with respect to your acceleration. Next question number 5, the brakes applied to a car produce an acceleration of 6 meter per second square in the opposite to the motion. Okay, if the car takes 2 seconds to stop after the application of brakes, calculate distance it travels during this time. Okay, next, last question. Sixth one, a racing car has a uniform acceleration of 4 meter per second square. Full stop. What distance will it cover in 10 seconds after the start? Okay, students. So this much only in this lesson. So more about you are going to study in the next class. Have a nice day. Thank you.